Hi and welcome to this final video on how to generate your own infinite element snake. So if you remember in the last videos we generated a snake with infinite elements. Okay, so the problem was that we didn't have control, and this video is about this. So let's have a look. So the first thing, I'm using ROS Development Studio, which is a web-based ROS development environment. And what I'm going to do is I'm going to open my IDE. There we go. And I'm going to my simulations folder. And just to have a basis of what we need. So when we spawn a robot, any robot in Gazebo, you have to launch, among other things, the controller spawner. And the controller spawner needs some arguments here. These arguments depend on which joints you want to control, okay? Which controllers, which we are talking here. So in the config file, you'll have a very big list of snake body 0, 1, 2, 3, 4, 5. And that's okay if you have finite elements. The problem is that what happens if I change the number of elements? What if instead of 7 elements, I put 20? Do I have to add more elements here in the YAML file? Or if I put less, then I leave them? This is the problem that we want to solve in this final video so that we can spawn through Xacros an infinite element snake, let's say, the number that I want, but with control. But that means that you have to generate dynamically the YAML file. And that's what you're going to learn here. So let's go to do that. First things first. So how do we start? So the thing is that there are many ways that you could do this. I've done this way. I found it was the easiest way or the most simple way of doing it. If you know any simpler way, please leave it in the comments below. So the first thing is that I've created a script which is called start snake, which is a shell script. And here we have different elements. So the first thing is the Python. We launch with Python this script, which is configure files YAML generator, which we'll see in a moment what it does, but basically it generates dynamically a version of this file, depending on the number of elements that we use, okay? And then we launch the init snake and elements that we created last video, where we used Xacros, dynamically generating more elements with Xacros. And we give it the number of elements and the number of controller args, so that we'll use to add in the launch file. It seems a bit complex. Let's go step by step. So I think the best way is to see how this init snake and launch works. So let's have a look. So here we have it. So this launch file has 2 arguments, input arguments. One is the number of elements, of course. So if I want to have a snake of 7 elements by default, and then the controller arguments that by default we give the basic controller arguments. Okay, so what do we use this for? We use it for the spawning of the snake And what do we use the controller args for? We use it for the controller. Okay, so let's have a look first on how do we spawn this. So the spawn full snake n, let's have a look, spawn full snake n. Okay, so here we have this argument that we pass to this spawn Xacro launch. Okay, here you go. This value goes here and enters into this spawn Xacro launch. So let's have a look. I know it might be a bit confusing, so I'm going slower and I'll repeat all the steps. So here in the spawn Xacro, where we spawn the Xacro, we have this number of elements that we give to the Xacro. This is fundamental and the core on how do we pass this argument from here, well, basically from the script here, ROS launch here, to the init, and into the spawn full snake, and the spawn full snake into the spawn Xacro, and it's the spawn Xacro that does the magic, because what we do is we load into the ROS parent the robot description, the Xacro, with this argument, which is the number of elements. And if we go to our Xacro, which is, by the way, it's snake controllers n. So let's go here, and we say, okay, where is this? Well, we have it here. Number of elements, which is a property of this Xacro, and here we have it. So prefix. Why prefix? Because we state it like this. So we said prefix equals blah blah blah. So here is where the Xacro gets that value that we input through this command line in the script, goes through all this launches until it arrives to the Xacro, and then here uses the structure that we talked about in the previous video to spawn as many elements as we need. Okay, that's the pipeline on how do we, through a simple command line, we spawn a snake of the elements that we want. Okay? Okay. So now let's go back. Let's clean up this. And then we say, okay, what about this one? Well, this one goes to the snake full control. So let's have a look. Snake control. There we go. In here, we see that we have it around here. And this, if you remember, for example, the full control, so this one, we go to this snake full control, which is this one. And here we have this controller args as input to this controller spawner. So we see another example with values. You see that we have these. So body joint position controller, in this case, we only used one, and then the joint state controller and some variables for configuration. Okay. So in this case, we are giving it through an argument and say, okay, but this argument, what value does it have? So it has this one. And what's that value? Well, that value is the contents of this file, the same way as this one is the contents of this file. So let's have a look. So the contents of these files is, in this case, for the controller args temporal, it's this. So you see, it's a list of all the controllers that we have. In this case, we have 20, but we could have 3, we could have whatever. And yeah, so here is this file here, So it gets the contents, and this goes inside here. That will be passed through this to the snake full control. Okay? And the same happens with the number of elements. We are passing it through this file, which is called num elements temporal, which is around here, which in this case is 20, because I did tests before. Okay? So the question is, okay, how do we generate these files? Do we do them by hand? Imagine that we have 30 elements or 100 or 1000. It's impossible, right? So that's the job, to generate these files and modify them based on the number of elements that we want. Let's clean up this a bit. So this is the work and the job of this config files yam generator py. As you see here, we'll only just launch this start snake with this number, and this will some way magically generate this file with 20 elements and this file with 20 elements. So in this case, this one will be a list, this list, and this one will be this one, which states basically the number of elements. Okay? So how do we do that? So this is the final step, which we go here and we say, okay, we go to this config files yam generator, which is this one, and this is the code that uses this to generate both these files and also the file for the controllers. So let me just go to this full control. If you remember, these are the arguments which we are passing, but also it needs this description, this snake full control, which would be these, but in this case it's using snake full control temp, which is here. Snake full control temp, you see, which is a YAML file with all the structure, with the publish rate, with the joints, with the PIDs, all this kind of configuration. So this Python script does all of that, generates these 3 files. Okay? So let's go over the code. So it's a simple, just I'm getting the argument, the first argument to get here the number 20, in this case. Then it prints, and then it generates the 3 files. You see, this one, and this one. If you go inside them, basically, I'm not going to go over all the code, but basically what it does is for the 2 basic ones, so for num elements, the number of elements, and the controller, which are not really YAML formatted, just a list. I'm using YAML just for having all YAML files. What it does is, let's have a look, for example, this one. So, there we go. So it generates the data, which in this case, it's a list of all the joints, so in the different formats, based on the number of elements, of course. And then it just fills the data. Okay? This one and the other one works the same way. So this one, the number of elements does exactly the same thing, fill file with the data and the number of elements into the file, but also it gives a list of 1 element. Okay. The one that it's more complex, which we are talking about, is the generate controller config, which is the one that would generate this YAML file, which needs a bit more of care doing it. Okay. So if we go here let's have a look. So we go here, we see we generate the data, and we fill the YAML file. Filling a YAML file is very simple. You just input the data, which is a dictionary, and that's it, nothing else, okay? The thing that gives more work is this one, generate the controller config data. So let's have a look. So here in this case, I'm just hard coding this, but of course you can put it here as a variable, of course. This is would be like an improvement of the code. And basically what we want is a structure like this. Okay, so what we start is with a content dict, which is this part here, this part. And we append these elements, because this one, it's always needed. So we start with that one. And then we append all the elements for the auxiliaries and for the normal ones based on the number of elements, and we convert it for the format that we need. Just the thing, why do we do this, float, string, and not use the integer? Well, because in the Xacro, for how Xacros work, the joints are named with a floating point. So 1.0, 1.2 instead of 1. That's why we are doing this. So we fill up the dictionary, and then we append it to the main dictionary, which would be namespace, snake, and colon, and then this one. Okay? And then we fill the data. And that's it. So let's have a look on how it works, how it performs. So we are going to, let me put a shell here. Okay. Going to put this here. Let's go to the simulation, source, parcel, snake scripts. And then I'm going to, for example, let's have a look to the script. We don't need this anymore. And we're going to do a snake of, let's say, 5 elements, for example, 5 elements. And I'm going to do the start snake. So we don't have anything here. So then we go here and we start the snake script, which will generate the scripts, all the configuration files, and will launch. There we go, connecting. All the controllers are working. And there we have it. It doesn't fall just because the controllers are working. Otherwise it would just fall on the ground. Okay? Okay. Now, there you go. But it's still working. Just that the joints don't have the enough force to stay upright. But it's working. To test that, we go to here and we launch the RQT GUI, for example. ROS run RQT GUI. And we have to go to the graphical tools, which I'll put here just to make it easier. Okay, I have it already prepared for some elements. So for example, let's activate, I don't know, number, well, because we put 5, the maximum joint that will work is 4. So let's try 3, for example, I don't know. Yeah, sine I 100. for example. Let's activate it. Let's see if it moves. There you go. So in this case, this is 3, which is this one. There we go. But we can activate the others. So for example, number 0, I think I have it. And there you go. Let's activate that one also. So that one's the 0. So it goes, the last element is a 0, and then it's 0, 1, 2, 3, 4. Okay? Yeah, that's it. So we can stop this, for example. Let's stop it. Let's close it just for being clean. Then we go to the shell and we stop the controllers. And then let's remove the snake. And let's change it to, I don't know, like 25. I don't know. Okay, so let's do this again. Start snake. 25 elements. There you go. It's a bit slower, of course. And there you have it. There we go. And that's a good thing, that now we can go here again, launch the RQT GUI, and move any element. Now we can move the element 20, joint 24, I say, which would be this one here. So let's have a look. For example, but because it's not in order, let's just pick this one. I don't know which one is it. It's number 2. Let's activate then, I don't know, 14. This one. Join 14, which is around there. It's trying to move there. Okay, let's look for, I don't know. Because it's a dictionary, it sometimes doesn't do it in order. Yeah, 21, that's good for me. So sign I 100, and then we activate it. It's around that one, but because all of them are rigid, then let's just, for fun, just activate them all. I don't know what will happen. It's because not all of them have values. For example, this one doesn't. So sign I divided by 100. There we go. It's trying to move each joint, but because others are not moving. But yeah, so like this, you can generate a snake of any length that you want, totally controlled. So I hope you liked the video. Give us a thumbs up if you liked it, and stay tuned for more videos. We are currently going to do a snake project series videos, and maybe another project, special project for you guys. So stay tuned, subscribe if you haven't, and see you soon. Bye.